Hello, welcome to Section 3 of the Firenock Dealer Certification Program. And this system is about Aero Systems, this whole segment. Now, what is Aero System? Aero System is the component system we made. Actually, we make two different sections of the Aero components. It's called an Aero System and an Aero Concept System. Now, Aero System is any component we made that can be easily used without a different segment of carbon tubing inside the traditional aero components. And the aero concept system is any time that a carbon inner tube is involved. That itself is what because it's so involved and so complicated, we dedicated an entire segment to talk about it. So right now we only talk about that component, just an improvement of what a basic aero component system is. That reason is called the aero system. Now inside the aero system, the first component we're going to talk about is aero bushing. What is an aero bushing? Why do we need bushing to start with? The fact is that when the aero go to a certain size, especially when aero exceeded 2364, which is about 315,000 ID, a normal NAC no longer works because the polycarbonate has to be so big and so heavy in order to function. People think 0.315 inch is not really that big. It is actually quite big. It's about 23/64 of an inch. Now, if you look at it, that's about 9 millimeter. That means anything that exceeded 9 millimeter on OD, the aero bushing system come into play. You say, why can't I just go ahead and make a NAC? Yes, you can. Some people actually do. The unfortunate part is that the moment you make a NAC, the NAC is going to be over 30 grains. And of course, there's other competing systems that will do that. We focus on this because this is the lightest system that we can think of. For example, like if you use this is 315 thousandths, which is called the ABU 315. This itself weight about 7 grain. The moment you put an ANAC in it, which is the 0.204 size NAC, this whole component system now, NAC and bushing combined, is only about 12 grains. Now, if you look at the traditional one, say using a traditional bushing, maybe an ANAC, even a GNAC, or in some people prefer using the OS NAC, you're going to exceed 30 grains. But in the case, and on top of that, you also have other issues. The first issue you're going to find out is that this piece is so specific, it can only fit one specific aero that was designed for. As we had learned in technology, 315 is not 315. Now just for example, 315 size aero. Like in case of Firenock, we make the Aero Weave 315. In the case of Element Aero, they make the Rock, which is 315 plus and minus 1/2,000. And in the case of Black Eagle, they make the Challenger PS23. They claim it to be 315, but you know there's always that tiny bit difference. So how do we overcome it? Take a look at this. Our aero bushing, unlike any bushing, it is not round, but technically squared. Yes, square peg in a round hole. But this is where the beauty is. You see the arch right here? It is not a flat spot, but an arch. So the moment when you fit this square peg inside that round tubing, we're using the ability of the aero shaft to concentric this piece. Because if you use a round piece in it, the only way you can fit it inside a shaft is by putting, say, a Walmart bag, some cellophane tape, and so on. But when you do that, you can guarantee not to get concentric from these 4 points. Or in the case of round tube, your Walmart bag is not going to be evenly spread. What does that mean? The moment you put the bushing into the aero shaft, you're guaranteed non-concentric. And at the same time, when you want to tune the NAC sideways, unless you can perfectly turn the NAC inside this hole, the whole bushing is going to shift. That's the first problem people see. Now, why do we go through, and as you can see that, see these 4 points right here is what's going to push these 4 points out. So what happened is that this circle is going to deform to be slightly off circle, like a 4-pointed circle with 4 edges on it, which means that using the elasticity of the aero shaft will guarantee the pressure and the consistency of the bushing inside the shaft, which make it concentric. The second, by maintaining consistent pressure, you can tune the NAC. Third, you're not going to add any material in it. it will always maintain snug. Because see, we push about 1,500 in here. That means technically this bushing can handle 0.314 all the way to 0.317. And of course, we did make all different sizes. Now, 2020, we renamed all the bushings. Why do you want to do that? Because in the old bushing were based on the English system, it gets very confusing. But now we decided to go the English system, but we go decimal. So instead of calling it 2264, 22.364, 2364, 2464, no. We decided that we are going to name based on the internal diameter of the shaft. So this becomes 315, 320, 330, 3435, all the way to 383. Now, you notice that we leave this space, and what there's another very unique features. See this lip right here? This is what the beauty of the Aero concept system, Aero bushing system is. It's called the umbrella collar system. You notice that we actually put a 45-degree undercut right here. See that, this undercut? That means when a shaft hit anywhere here, from back hit, it's going to glance off. When it click close to the shaft, it's going to hit this, deform the aluminum, and do not damage the shaft. That's the beauty of the umbrella collar system. Yes, there's 2 separate patterns we filed on this single piece alone. Now, so what is the benefit overall? Now you end up with a bushing system that's guaranteed concentric, able to handle back hit, and the most important is about 30 to 40% lighter weight than any system out there. The next thing we want to talk about is outserts. Outsert first been seen from the days of the Beamans. We're talking late 1990s. So we're talking close to 30 years old. So what's the big deal about outserts since it's such old technology? Well, outsert used to use on Aero like the 200, 202, 205 size. But now we at Firenock see a lot of newer Aero in the 166 class come out. And outsert become a very big deal. Now let's look at this outsert that typical people use. Let's point out a few components so we understand each part. This piece right here, all the way with the thread stopping here, is the fill point. This size is based on AMO standard, okay? In most cases, everybody's 166 outsert, half out, is from this point to this point. So in other words, if you look at this diagram, where's the fill point? The fill point is sitting this far, which means this distance right here from the shaft. That's the minimum it has to be because the fill point had to screw it all the way in, but the end of that thread is in front of the shaft. See this distance? Even if you thread all the way down, you still have this distance. That means if you look at this diagram, the fill point, the insert, and the shaft, all 3 have no overlap, isn't it? Which means the moment you look at see, this whole design have one major problem. The moment you hit, which is the load, this is the first fulcrum if the material itself is not strong enough. This is the weakest link. So the entire length, which is this distance from here to here, is going to force this piece to bend at this point. Now assume you use all the way to highest, strongest material name known to mankind. Actually, it gets even worse. This time, the piece is not going to bend. The carbon's going to crack at this point. Because now look at the effort here, which is where the lift is. The whole load effect with the length based on this fulcrum now. Now think about it. That means if this arrow hit at an angle, this part is going to bend based on the ability of this section. If this thing is strong enough, it's going to bend based on this section right here. So none of them are good because look at the distance. This is more than the entire fill point. Now this is just a fill point. Whatever is a broadhead, you're going to add this much to it. So the distance becomes even more dramatic. Why it is such important for, say, the first fulcrum? This first fulcrum is based on the material science because the entire portion, see this circle right here? That's the cross section of the material in here. That means the maximum you can get in strength is on this rod of 0.166. That means if for this thing to bend, it's bending this rod with the load of this surface right here. See this? That's the load. Now that's the effort. That's the load. And that's the breaking point. You only got 0.166 of whatever material you got. Now let's talk about it. Some people say, oh, I will go ahead and put a collar on it. Look at this collar. It covers from here to here. Okay? So that all of a sudden, the material itself is this plus this. Now you got to extreme a lot of material. Now why is it so bad? Well, some people consider it good because now you have more weight. But at the end of the day, your load, you're going to break the arrow right here. Why? Because this whole section do not bend. It's not part of the arrow. And then you imagine you go ahead and add a broadhead. Your distance from this point all the way to this point, and the arrow going to break right here. And not to mention the humongous amount of weight. Well, so why are we still looking at outserts? Because outserts are very common. And unfortunately, in the 166 class, which is based on the centerless grind process. Yes, it's not based on a center, but it's centerless. So if you look at most of the 166 arrow shaft, you end up with this in the front. This exaggerated, which means the wall thickness of the 166 not always perfect. Which means what? The moment you put an insert in it, even you put a ballistic collar, you got to sand this part off just to fit it. Yes, some manufacturers make better pieces, but the fact remains, when you do a centerless grind, which is what involved in 166 manufacturing process, this exists. So, what did we Firenock do? We take the whole thing right on its top. First of all, we go with the original concept of the outsert system. But why is the outsert system so difficult? Because see, when you look at this field point and compare to others. See this field point, the end of the field point is in front of the shaft. Look at the end of this field point. It's into the shaft, even so small. The second portion, you notice that the outsert system is actually from here to here. Look at that. This much is overlapped with the carbon, while this inside is overlapped with the carbon. But now look at the most important part. Just like in all physics of tubings and rods, this is actually going to be less than 1/5 the power of this. Because see, when you look at the diameter size, this is an 8mm diameter compared to less than 3.5mm diameter. That is just by physical size is close to 450% difference in size, which gives this extreme strength. Second, look at where the fulcrum is. The low is the F low is here, and the F foot is only here. That means at the weakest point is where this whole system is the strongest. Look at this. The carbon tubing, the outsert, and the field point all share the same plane. Now what this does is that, and not to mention, see, when you look at everything else, you want to look at the actual impact, which is the load. Assuming I'm going to put it this long, this point to here, compared to this point to even here, that is the difference of here. You can see the difference itself, actually. See that? But most important part, none of them are important. The carbon tubing and where the insert overlap is. That itself explains why the arrow outsert is superior. But then people say, well, you know, what's wrong with the old outsert? The old outsert is nothing wrong. The problem with the old outsert is that when you make an outsert, this is what you need to do. You need to have this tubing, rotate, machined, drill on this side, then rotate the whole thing this way and drill again. Anything before 2000, if you want to do what I just described, it's going to be extremely expensive. And second, this is a piece of aluminum. Until you're willing to do forging process, the best you can do is 6061 T5. This is 6061 T6. What's T6 about? It's a forging process. Gives you extra 15 to 18% more strength. Which means that this whole unit right here only weighs 31 to 32 grains. When you say, well, I have went through outsert all my life, it was really no good. The moment you shoot into the meat or shoot in the target, it catch and don't come out. Well, that's where Firenock outsert difference. See these grooves right here? This is where outsert becomes different. See this groove right here? It's the same concept as this groove right here. That's the reason we call it the blood channels. Now see, in the old days, the moment your broadhead cut through it and it go through the animal or a target, the animal meat will now shrink and grab the tubing. And instantly, when the meat hit this section of the outserts, because this is from thin to thick, you got a wedging effect. The wedging effect will hold the outsert from being removed. So what does this channels here, now of course this is not a good diagram. If you look at the actual product, every one of the grooves are slightly different. And slightly different depth and slightly different width. The left and right is mirror image, of course. What this we actually do is that this groove on this edge behave like this groove on this edge. That means it's cutting any meat that try to grab hold of this section right here. That's the reason there's a slope right here of this groove. So in other words, the moment when you pull this outside from meat, all this groove will behave like tiny edge to cut the meat. The moment you cut the meat or cut the fabric of the target, what does it really do? It actually releases the pressure. That's the reason this is the first outsert ever you can shoot into meat and able to pull it out as effortlessly as humanly possible as an outsert. Of course, you cannot compare this to a normal insert because that is a change of diameter from a media. But this is the best we can come off. Yes, it was so good, we actually got a patent on it. Now then people say, well, you know, how come you make 17 ouserts? Because there's that many aero sizes out there. And in order for this to work right, you really need to be within no more than 2 thousandths of where the shaft is. If the shaft is 610,000, you need a 612. Can you be more than 3,000 or 4,000 answer this? Yes. But the 3,000 and 4,000 have a major problem because the outside and inside, you may end up with an arrow with a little bit this. Now, this is not an easy process to install. So in the near future, we're going to give you a detailed video of how to install the Aero outside system. Okay? Now a lot of people say, well, you know, it's not that difficult. Just like everything else. It's simple to do it okay, but it's difficult to do it perfectly. And we're going to discuss this when the video comes out for installation of Aero outside only. Now for the people who already done it, the bottom line is it's pretty simple. You make sure the inside is clean and scratched. Yes, and scratched. The shaft is clean with acetone and scratched. Then you put that on it and using our APS. Alright, next system, we want to talk about inserts. Yes, this is basic concept of an insert. That means we are talking a piece of metal that over 80% or 90% of it is inside the aero shaft. Let's talk about traditional inserts so we all talk about what it is. We all about when insert first comes out, most people just barely cut it with a hacksaw, whatever they do, glue the insert to the aero shaft and assume they are good. We already know that that's not going to happen. That's the reason I sell so many APS, because it's called aero preparation system for people to square the shaft. Most people don't understand squaring a shaft if you use an insert that have a flat shoulder is critical. Because if you don't, the moment you shoot this arrow into the target, you got this gap right here. That means the insert and carbon is not supporting the load. Eventually, the glue on this side will crack up, and this will move forward, crumble this side, and your insert will fall out. Because you allow this gap to exist by not squaring the arrow. Now that's the first problem that 90% of uneven squaring out of the arrow shaft towards the insert will be. Now even if you do that, perfectly squared, glue perfectly, the moment you hit the target into an ultra strong object, like you miss the target, you're shooting the rock, you will find out your insert will push itself inside the shaft, and this too is the frame of your shaft. So what's the point of squaring it? The fact is that an arrow, when hit target, you will do 3 different oscillation. The first oscillation is called circumference oscillation. The shaft will go like this. The second, the tail shaft, will go like this. The third one is going to rotate itself like this. The worst part is that the moment when the shaft go like big and small, because of impact, the moment it reaches the critical point that's larger than the insert shoulder, the fabric will go over it. This whole thing split happened in literally 2 or 3 microseconds on impact. So that's the reason a lot of people, when they shoot the arrow like a field point into a rock, they will find the insert got pushed inside the shaft. So, how do we overcome all this? We at Firenock actually own a patent called the reverse taper technology. You can see that our insert is made not flat here, but 45-degree tapered here. What does that really do? This is actually a very big deal. You notice that when this shaft, if you simply chamfer this part off, as it goes forward, guess what? The arrow shaft is forcing towards the metal all the time under condition. You're never able to do this because the edge of this carbon shaft is reverse taper contained. So the force we're going more and more and more towards this insert. So as long as this insert is well made, like ours is made of 70-71, except we do make 60-61 for our dealers because of price points. All our inserts made of 420 stainless, 303, 70-75, and GR5 titanium, which make this section extremely strong because the material is so strong. So when you hit it, the shaft try to come out, guess what? It's going to be blocked by this 45-degree reserve taper. It can't go out. It'll go in and self-tighten, self-centered. Okay, now what is concentricity? Now remember the previous diagram, we talked about how you square the shaft perfectly? And just so you know, in every single case, the insert has to be smaller than the shaft, otherwise it can't go in, right? So if it's smaller than the shaft, you square it. How do you guarantee your insert is indeed in the center, like in this diagram? It's exaggerated. You can see that there can be more glue on this side. So assuming that you are a 246 ID and your insert is 244, you spin it and the glue is glued on it evenly and you sit it on the table like this. This is your table. Within a very short time, your insert will drop down there because the glue is not set. Now your insert is off center by 2 thousandths. Remember I say 246, 244? This is 2,000 difference. So how do you overcome this? Very simple. We already know that the moment you apply force, as long as there's angle, you always go to the lowest point. Just like if you throw a ball into a funnel, guess what it's going to be? It's going to be at the bottom of the funnel if the funnel is facing downwards. The same thing with Firenock. The moment, you remember the previous program, the diagram we showed, this is now a reversed. Now you have 245 degrees on both sides. This entire thing is going in. Even if it's about 3 thousandths out, the glue will flow evenly. That's the reason, unlike other insert system, that you must lay the table arrow flat on it. We at Firenock recommend that you stick your arrow perfectly straight so that the cap with the reverse taper will sit perfectly on the arrow shaft itself. And that's also the reason we suggest not to use super glue, but using ultra slow set epoxy, which has flex in it. That means after you shot it, it will self-center and self-concentric. That's the beauty with all the Firenock system that we developed. It'll give you that. Now let's take a look at it from this point of view, so that you can see how an insert actually works. See that? This is a carbon shaft come to it. See that 45 degree right here? See that 45 degree right here? This is the AMO called chamfering on both sides, with the shoulder and then the thread. And of course the glue go on these spots. But the fact is that if this is off by a little bit, the fact is that we chamfer this will self-center and self-balance. The glue will always go evenly on both sides. Even if it doesn't, within a few shots it will set. That's the reason we do not want to use super glue, because the moment super glue, when the insert moves, it will break the bonds of the super glue and the whole thing is gone. Now, you look at it. We make a lot of arrow insert A. Why do we call arrow insert A? Very simple. Every one of the shoulder right here have a 45 degree reverse taper in it. The Aero insert gives us a lot of benefit. We go from what you call the basic insert, quarter out, and half out. Of course, in 204, it's not possible to do a full insert because see, this neck right here is going to be bigger. Like 204 is going to be what you call it the 5mm size. And when you try to put F8mm fuel point right here, it's not going to go in because you will lose this entire piece. That's the reason in the 202 size, we call it the half out. Now in case of the 235 size, you can see this is bigger. This is called a quarter out. And the 246 size, it is a true insert, and for in extreme cases, like when we want to produce a product with extreme shoulder for ultra high impact, you notice we will now increase the entire shoulder height significantly. And we make this all the way to the size of 23.5/64, so 320 thousandths of IDs. So you can see all the sizes. Now, a lot of people, when they use our insert, they will say they'll compare it to one of the older technology. I won't say that old, it's about 18 years old now. It's called the heat insert system. What's the difference between the heat insert system and what we do in Firenock? You notice a heat insert system, as I say, is a hidden insert system. So the insert is actually glued into the shaft at a certain depth. But when you glue this insert in a certain depth, that means that you cannot possibly have this insert glued vertically. It has to be horizontally. And the next question you have is that if this insert has to be inside the shaft with the glue, there has to be space between the insert and the shaft, isn't it? Which means that the moment you glue this insert, the insert will sit towards the table. Which means that this insert is guaranteed to be off-centered. Because it cannot be perfectly centered. Because if perfectly, it cannot be glued. That's pretty much the end of it. So how do we overcome this? This is how we overcome. You notice, unlike others, we give a big gap in here because our insert right here is actually 201 thousandths. Yes, this Aero insert A for the 204 size we have will fit from 205 all the way down to 201. So you can actually have 2 thousandths on both gap on both sides. And you have this whole shoulder in front of you, which protect the aero shaft. Because when this fuel point push on the insert, it's going to be chamfered before you touch the carbon. Now in the case of the HIT insert, the moment the fuel point hits, guess what it's touching? The carbon immediately. That means every time, the moment you hit it, now you understand why your HIT insert fuel points or broadheads, every time you shoot, you get loose. Because this part of the carbon will be crumbled. Because it's direct force over it. And cause this part to be loosened. Because no fuel point will hit the target perpendicularly, perfectly centered every time. So if it hits sideways adjustment, you're going to crumble the carbon on both edges. Now, but with ours, is our Firenock's Aero Insert A1A 20 series. You can see we got this much metal to protect this. Well, what is protecting this neck of this fuel point or broadhead? Answer is nothing but the carbon tube itself. See, this part of the carbon tube is what holding this insert. If you look at the leverage, just like we talked about, this part is actually pushing against this. And you look at this, the moment you try to push, the self-center will actually force the force to be in these two spots. While in the meantime, the weakest link, remember we look at the back of the fuel point or broadhead? This is supposed to be the weakest link. Guess what? Again, it's carbon, insert, fuel point, which is also true in the HIT. Carbon, insert, fuel point. But the difference between these two systems is there's a significant amount of material right here. This material is right here to support it, to protect the carbon from crumbling. Okay, that finished it, but we're going to talk about something interesting and something totally new. We at Firenock just filed a patent on what we call the stalker system. This is the first ever a system is made for the 166 class. Yes, we are against 166 all day long for the last 5 years. But since so many customers love it, we decided, well, if we can't convince you, we're going to show you how. You notice that this is traditional way we do an arrow insert with the fuel point screwed into the shaft with into the insert protecting the shaft, right? How are we going to do differently than this? Well, we're going to turn the whole thing upside down. Because the 166 is so small, we actually grab this section and reverse it forward. We call it the stem system, which is what we call it, the trademark is stalker. What happens, see that we got the same reverse taper right here. See that? Same as here. We got to insert thread right here, except we reverse it of this side and put it forward. And just like our arrow points, you got 2 O-rings right here. So what does this give you? This gives you a 166 system, have the traditional capability, and easy to change fuel point. And you notice that, just like all Firenock fashion, see that there's air can pass through it right here. See that? Even in our stalker system, you notice a tiny thin hole. You say, Will, it's crazy. How do you drill that hole? You notice that every single manufacturer is trying their best to be cheap. So they all decided not to drill the hole. But if this shaft is 0.166, how do you drill that 0.5 millimeter hole? Well, you know, we at Firenock always push the technology further than anyone else. We actually use EDM to drill this. Yes, electromagnetic discharge drilling. We actually drill this with copper and electricity. So we say, why is this hole so important? Well, at the end of the day, we are Firenocks. We make lighter knocks. And in order for you to install a lighter knock in this arrow perfectly, you need air to pass through it. We do not forget our roots. So even on stalker on a 166 shaft, we still drill this 0.5 millimeter hole for the air to pass through. So let's look at this stalker system. That's what we offer in the A class, which means no carbon tube involved. Now with this piece with the 2 O-rings, you can put any of the fuel points out there and complete the system. Think about it for a second. This is the first time ever in archery history you can change the fuel point weight on a 166 class reliably, consistently, and without shaking it loose, and without gluing the fuel points. The fuel points is changeable because of this 2 O-ring. And this is a strong. Why? Because when the fuel point touches this, this is going to this reverse taper, and you got this thing to support the shaft for the glue. See, that means we have applied everything we learned and patented. By the way, this has got a brand new patent pending on it for anybody who would like to know. Now, see this? Remember we talked about this coming through, how the OAM, ATA standard or the OAM, or the OAMO standard, we still maintain all the standardification. The chamfer, the 832 thread, the neck length, and so on. So what is it about? What can we do to improve it? Arrow points. Yes, a basic fuel point. But people don't understand the fuel point is one of the most important things because you can't practice perfect, you can't make hunting perfect. Every time when you put a fuel point into the shaft, in the traditional way, you put wax all over this place and hope that it's concentric. And after a few shots, the fuel point got loose. To the point you finally put some glue on it and hold it. And then you end up not able to change it. We at Firenock don't think that's a good idea. That's the reason we have the arrow point pattern. See these 2 O-rings? Actually, just like a pipe fitter system. The moment when you have this piece pushed into a shaft, which I can show you, push into this shaft, guess what? The O-ring is going to hold this part. And what we said, the insert is concentric, which means that the fuel point will concentric the insert, which will concentric the shaft. And every time when you push it in, the 2 O-ring will self-concentric the fuel point and make this fuel point not loose. That's the beauty of the arrow point. We will not license this technology to anybody on the fuel point, but we do license this technology to anybody who make broadheads. That's the reason you can see a lot of broadheads using this technology. Now, how many fuel points we make? Answer is a lot. We make 2 different classes of fuel points. Yes, only 2 on the arrow point size. Of course, stalker points, destroyer points, they are different ball game. Or also arrow concept points, but we will talk about it in arrow concept system. We are talking basic arrow points. 832 thread going into a 10.5 millimeter shoulder with the 8 millimeter for the normal regular bow, what we call vertical bow, to the 9 millimeter on the crossbow and the target systems. So you can see we split the thing right in the middle. And the unique one is this one. This is a 9mm, but only weight 45 grains. 45, 45, 55, 65, 75, 95, 100, 125, 150, 175, and 250 on the 9mm size. People say 250? Is that crazy? No, it is not. Because see, when you start going into Vegas or the indoor competition, you need that 250. And for the people who do Africa big game, you need that 250 because there's a lot of broadhead in the 250 range coming out. That's the reason we also make the 150, 175 too. So you can see that on the 8mm size, we maximum is 175, smallest is 45, and on the target side, the 45 all the way to 250. Okay, we are finished with quote unquote all the mini components for practice. And let's talk about killing. The first broadhead Firenock ever made is the Tomahawk. Why is it called the Tomahawk? Actually, it's a take-up word. It's actually Tomahawk. It's 175 grains. That's a mistake right here, which is no big deal. This is going to be 175 grains. Okay? And you notice one major important thing is that you do not have a point in it. It's a complex single bevel. In other words, it doesn't have a point. It has a line. Yes, this viewpoint this broadhead do not have a point but a line. So in other words, you can consider a chisel tip. It is a chisel coming through, but you can see from this GIF, you can see that you have two separate surfaces, top and bottom, to give you the maximum rotation after you reach inside the animal. It will rotate the opposite way towards the chisel plane, which is right here. This is made for crossbows or also for traditional archery. Technically, you buy one for life. There is no reason to sharpen it because this is what we call a blunt force trauma broadhead. In other words, we want the broadhead to expend all the arrow's energy while inside the animal. And but you also say traditional bow, right? Yes, this is fantastic for squirrel, rabbits, and anything that you want to kill without needing sharpening. Because see, this whole thing, literally, this broadhead, when you receive it, all three edges on it is not sharp. Because the idea is not to be sharp. You want to expend the energy while you put through the animal. Now, from that, you notice that, let me go back to the previous picture and show you one thing. See this edge? It's two edges right here. See that one edge? Two edges. Two 17-degree edge. Now, people say, this is great, but I shoot vertical bow. I need it to expend less energy, reliable, give me all the capability. Well, very simply, now look at what happened. Now imagine there's a line right here. From this point, we now do a secondary grind from this point to this point. Guess what you end up with? Dagger. See, that whole chisel point is cut in half with this grinding of this surface and end up with a point. But if you look at the point of this, see that when you come down, you end up with 4 different surfaces. Yes, this is not a dual edge like most people would believe. It's a complex single bevel. So in other words, this is the main single bevel. That's a secondary single bevel. It's a complex single bevel. Now, why is complex single bevel so interesting? And why is there other feature in it which I have not seen much? If you notice that there is actually a bevel edge inside of here. Which means that the moment when this broadhead cut the animal, not just rotated by single bevel, you're also using caputation process, using this area right here to create low pressure. So this broadhead is extremely quiet. And you will cause a lot less internal bleeding because the moment you create low pressure on this area. Now, of course, this low pressure can only be created if this arrow is spinning over 150 revolutions every 20 yards. So this broadhead will lose this capability and maintain like ordinary broadhead. If you use blazers or even arrow wing 2, you only have the added capability of this segment to it if you are using arrow wing 3 and shooting over 315 feet per second. So this is a fantastic design. We got a patent pending over it. What can we do more about this? This is what we are going to do. Look at that. We're going to give you the entire line of of daggers. Besides the first one you see is 85 ring on the titanium dagger, we're going to make a new 100, 125, 150, 175, 200, and 250. The beauty of all of them is that they're all going to have the same bevel on this side, except the 250, because it is an ultra big game. We'll tell you more when it's available, not now, because it's a lot more complicated than usual. Until you got one in your hand, in your dealer is going to, which is the one who is taking the class, will get a lot more documentation on this. This is going to be a very, very exciting series of broadheads. Yes, they are definitely not going to be cheap. They are made of 156 stainless, and then a new process and hardening. So this broadhead, technically, if you're not into ultra big game like elephant, Cape Buffalo, and so on, you don't need this. Okay. One of the most exciting broad pattern that we ever got in Firenock is about 2 years ago. We come up with a concept called the swing blade. Well, let me tell you a little bit of history about this swing blade. It's the reason it's fun because, see, I was driving up to Chicago and somebody's door didn't close and it swing out while I was driving. That very moment is where swing blade comes up. Because I figured that if you swing out like this, why can't broadhead do the same thing? You know, every single broadhead in this world, they come out like this way. Our broadhead blade come out like this way. Why is that such a big difference? Now we learn everything we learned with the previous daggers and tomahawk. We actually want to use this on this specific broadhead. At the same time, we also learn the old chisel tip is one of the best. So, first of all, we start with the old chisel tip, okay? Then we make the body in 3 different weights, which will give you the aluminum, the stainless steel, and the heavy stainless steel, which means we'll give you 75, 100, and 125. And this year, we're going to give you 4 blades, which is the Falcon, the Raptor, the Talon, and the Saber. Why do you need all this? See, the beauty of all this is now all of a sudden you are allowed 3 times 4, 12 different broadhead using the same system. At the same time, you notice that we do a lot more to this system. You see the screw right here? You see the chamber right here? That's called a ram air chamber. That means the moment the air comes in, it hit the screw, which is the torque screw. The air will explode at high pressure on this point. And with high pressure, we become lower density. This lower density air is going to flow on top of this blade, which gives this blade the least amount of aerodynamic effect. Now, why do we still have 4 blades? Of course, if you look at the entire swing blade design, the number one, of course, is the Falcon. The Falcon is meant to fly up to 550 feet per second with no issue. And because of this barb right here, which is not a barb, by the way, the all Firenock swing blade, a single bevel grind on both sides. That means this side is going to grind on this side, and the lower part is going to grind, which is forward. So the moment when this blade going through the animal, the single bevel grind is what causes it to open. That means the cutting action is what caused this blade to open. If there's no cut, there's no open. Every other design, the moment you open, you use up energy. This design, the energy is used regardless, but by the way, it also opens it. The reason I make this 2 blade, because a lot of customers say, you know, I don't shoot crossbow up to 400 feet per second, I shoot regular bow. So at 315 feet per second, we've discovered based on fan law number 1 and number 3 and calculation, we can have a blade called a Talon. With a bit longer, you're looking about 1.5 inch. And then for people who shoot under 280 feet per second, our Saber would definitely do whatever you need. So one broadhead, you can pretty much use this combination to do everything you need. Except say, well, then why do we still need this tiny stubby piece here? Because when you're dealing with state that say no bobbing, this undercut of this piece is actually 89 degree, which make this legal for any state that have a no bobbing law. Okay, that pretty much tell you the whole 4 pieces. Now you can see that's the actual sizes of the blade. Now I just talked about it. Now you can see why this is so important and why every single piece have that capability. Look at the cut. The Saber, the Falcon and the Saber, the Falcon and the Raptor have exactly the same size. But when they both fly, it's only 3/4 inch. When they hit the animal, it's 1 3/16. If you can't kill with 1 3/16, I think you need to rethink about archery, especially with crossbows. But then this Talon is so exciting because this year I got a lot of report coming from my customers. If you don't shoot long distance, you put feather, not arrow vane, on your arrow. You can use the Talon and it become one of my top turkey head blade. I don't even know it, but my customer teach me. I didn't know what I made, so they teach me this is one of the best crossbow and vertical bow turkey blade. And for the customer who love a big gigantic cut with low speed arrow, here you got it. That's our Saber. You can see this piece alone, just from this point, is close to 1 inch long. And it opened to 1 13/16. That's bigger than anything I can ask for. That pretty much sums up the entire Aero system. And finally, I want to show you the deployment of the swing blade. See, the moment when it was shooting in the air, when you launch it, this is how big it is. See that? That is actual size based on, this is an 8mm. The outermost point of the blade is only 7/8. This is how much you get when you cut the meat. And then of course, this is the Talon, and finally, the Raptor. Saber. Okay, now you look at how the whole set will allow you to do. You can see aluminum, stainless, heavy stainless on the Falcon, the Raptor, the Talon, and finally the Saber. So you can see that just on this alone, on the head and body and the 4 blade, there's 12 of them. And later we're going to give you different head weights by 2021. If we make 2 heads, we just double this. We make 3 heads, we triple this. We make 4 heads, we quadruple this. Now, you can pretty much, just with this system, what else can you not do? If we make 125 grain into 150 or 175, this will give you 175 grain with a heavier head. Or we can look at this, we give you a 25 grain lighter head. This 75 become 55. You say, who need 55 grain broadheads? Well, we'll talk about more of that in Aero Concept Systems. Haha, very interesting stuff. You notice we make broadheads, we make field points, we make shafts, we make inserts. But we all know not everybody loves to use our system only. So what happens when you build an arrow, after you do all the adjustments, you find out 2 of them are, say, 2 grains lighter, or 3.5 grains lighter. What do you do now? We actually make, in these cases, I will take it back. In these cases, you notice that we make all the major broadhead in 8mm. And then some people prefer the 9mm heads. Why? Because a 9mm head will allow this space to go through the shaft easier. Just like a lot of people prefer the larger broadhead on a smaller shaft. The first thing we make is called a slant spacer. See, the slant spacer is 8mm on this end and 9mm on this end. Which means that if I happen to shoot an 8mm, 9mm arrow, or with an 8mm broadhead, I will have this space back again, isn't it? So I would just simply swap the spacer and use all mine. See, Firenock, another company, we only make one size broadheads. All our broadhead is based on 8mm. So if you want to use our broadhead, you have to buy this spacer and reverse it. Unlike Target, people prefer a 9mm field point with an 8mm shaft or thinner. The second piece we want to talk about, you see that, for example, like we say the arrow itself is, say, when you finish building it, it's 441 grain, well, 341 grain. For all 11 shafts, and you got all 10 shafts, and you got 2 shafts with a field point end up to be 445 grains. So how do you make them all aligned? We can add a spacer based on weight and also based on positioning. People say, what are you talking about? There's a lot more involved. Because you remember, at the end of the day, your fuel point broadhead had to work perfectly with your insert and the entire aero as a system. You want to make all of them even, right? So when you want to make all of them even, you have two choices. You either put weight right here or minus weight right here. Now we actually make three different systems. We make the slant spacer, we make the titanium, and we also make the copper. So why? Copper is for weight, and titanium is for broadhead tuning. This is the part most people don't understand. When you shoot a two-blade broadhead, this is where it becomes so important. The broadhead has to be vertical when you put on arrow. So when you got an arrow and you happen to put your favorite broadhead, a two-blade broadhead, and it was like this, it is not going to shoot right. So how do you do like most people? They will now they will glue the insert with the broadhead together and make sure it stays straight perpendicularly. So if you build some custom arrow, how can you guarantee that to happen after you break a few of the broadheads? You're not going to happen, isn't it? So on a titanium system like this, the 0.1 millimeter will give you 45 degree, 0.2 millimeter will give you close to 85 degree, because remember we're playing with a millimeter to 1/32 of an inch. Because when you look at all the AMO standard, this screw is 1/80 second. You see exactly 80 second, answer is no, a little bit different. So when we tighten it, they're going to be a little bit off. So that's the reason we make 5 sizes. 0.1, 0.2, 0.25, 0.3, and 0.4. So now you can technically do a full rotation of the arrow with very minor increment to adjust it. But on top of that, we already know that when you make 0.1 millimeter, is that all going to be 0.1 millimeter? No. It's going to be a little bit off. That's the reason you get a few more to play with it. That's the reason we got a titanium spacer is for broadhead tuning, the copper spacer is to add weight, and the slant spacer is to change and accommodate different diameter of arrow size. And finally, we want to talk about one of the two that we talked about in the early days, the arrow preparation system. This is part of the basic tool, and this is one of our top selling tools. Like if you have an arrow, do not have an arrow insert A, you need this to square the end, isn't it? Otherwise, the tip of the arrow is not touching the shoulder of the insert perfectly. The second part is that you want to insert square end out. Actually, we do not recommend this. But so many people thought it's important. Because if your insert is not square, that means you don't glue it square. Why would you even bother square end? But, you know, if you shoot traditional bow, that's not important. And this will actually give you a way out. Exactly, in most cases, insert end squaring is not recommended for any high-speed compound. The third one is the fletching knot end squaring. Now that part actually is very important, especially for people who use not a Firenock system, using contact system. Because when you use it, it's going to notch the hell out of the back of the arrow, and you will lose contact. But using this approach, you can. And the next one you're going to see is a broadhead and field point tuning. You see, you turn the thing backwards and you actually put a piece of paper there. Now you can using this to make sure your field point or your broadhead is. But if you think about it, this technically is eliminated. It won't happen in Firenock. The moment you put arrow point and insert it, you're self-concentric. So with our system, we technically make this, this, and this obsolete. But you know, not everybody use Firenock. We understand that. That's what we make do. Now, outside concentric. Now, this is the #1 reason everybody bought Firenock APS system. Because until you're able to flow the glue inside this outside concentrically, this is never going to shoot right. I got a full video on YouTube. You can see exactly how to do that. And finally, you can do a basic general spin checker. This is a general spin checker. A lot of people don't understand it. This is not to hyper spin the shaft and look at how good the shaft behave. If you do that, you need the APS SSS, which is this. Now, if you look at APS roller, this is original roller we make before 2015. There's a tiny bearing here. We no longer make that. Now we make the one with the same ball bearing we use in PAPS. You can see how big the difference is. But for people who really want to spin, we give you this. Why do you make it so big? It's very easy. It's pure physics. The circumference get bigger. The slower the bearing need to turn, the more you turn the shaft. That's all it is, nothing special. This color is discontinued as of February 2020. Now we make the new color. See that? This is now hard coat. So we make it even more durable. Now, but you look at this from the side view, you can see that now we actually give you this. See that how nice this part is? It's curved. That means when you flex the arrows are always on tangent with this curve, because this curve is based on 28 inches curve on the radius, not on the diameter. And if you look at this part, see the difference between these two? You can see a difference. You can see the circumference of this compared to the circumference of this. But we go one step further. You notice that we actually put an O-ring on the outer edge of this pulley. Why do I do that? Just like why do you put tires on your car? So when you spin this, the rubber is going to hold this thing consistently, and you can see the true spin of this. In summary, we make aero bushings, we make aero ouserts, inserts, half out, field point, and the stalker system. That pretty much completed the entire aero component system. Thank you.